Hello, future engineers. This is 3D equilibrium of a particle. This is part 3, and the challenging problems are on this part. Remember that you can only say that you learn from a certain course if you are attracted, you find special attractiveness to difficult and challenging problems. Because if you say you learned from a course and the problems are just basic problems, you are not learning. It's a routine. You are exposed to situations that are common. That's why you are able to answer them. But if you can solve problems in a different situation, challenging situations, then that's the only way you can say that you really learn. But if you are accustomed to solving very easy problems, like most of the vloggers here, there are bloggers from other countries who are very popular, yet students from the Philippines seldom appreciate their efforts because of the very fast explanations. And secondly, they cannot really catch up the flow of the discussions. I tell you, those are the bright bloggers. That's why I created my channel to catch those slow learners as well as those who are willing to develop their skills. That's why I included very challenging problems here. So I hope that you will be appreciating those vloggers who are sharing problems that are challenging, because there's no chance for you to grow, there's no chance for you to learn and to develop your skills if you just keep on appreciating vloggers who are uploading very easy and understandable problems. You are not developing yourselves. You stick to just low levels. So it's time for you to grow, to develop your thinking skills, because that is important for engineers. So I hope that this channel, which I created, a one-stop channel, can help you develop yourselves. And that's my purpose of creating this channel. Level 11, three cables are connected at A, where the forces P and Q are applied as shown. Knowing that P is 1,200 newtons, determine the values of Q for which cable AD is taut. When we say taut, meaning there is tension. Even if the tension is very small as possible, almost zero, that is still taut. Aside from being slack or it sags. So the trick here is when you have to set the value of tension AD and you have to set the value of Q. So let's express tension in AB in vector form. So magnitude of tension AB, negative 0.96 I. Let's convert it to meter. And it's going down along Y by 0.24, so minus 0.24 J. Then along Z, it's forward 0.38 K over square root of 0.96 square plus 0.24 square plus 0.38 square. Simplifying, tension AB is magnitude of tension AB times negative 48 over 53I, negative 12 over 53J, and positive 19 over 53K. Next is tension AC. Tension AC along X is magnitude of tension AC. Then it is going to the left 0.96, negative 0.96 I, going down negative 0.24 J, then backward negative 0.32K over square root of 0.96 square plus 0.24 square plus 0.32 square. Simplifying, tension in AC in vector form is magnitude of tension AC times negative 12 over 13I, negative 3 over 13J, negative 4 over 13K. Next is tension AD. Tension AD is going to the left, negative 0.96I, upward, so vertical distance from C to D is 0.96, but it starts at A, which is 240 mm above the XZ plane. Therefore, the vertical distance from A to D is 960 minus 240, that's 720 mm. So it is magnitude of tension AD times quantity negative 0.96I plus 0.72J minus 0.22K over square root of 0.96 square plus 0.72 square plus 0.22 square. Remember, 0.72 is 0.96 minus 0.24. So tension AD is magnitude of tension AD times negative 48 over 61I plus 36 over 61J minus 11 over 61K. So to be systematic, we have Rx is 0. So we have to set if Q is unknown and tension AD is 0. So if Q is unknown, then tension AD is 0. That's part of the analysis. The tension in AD is still taut. We follow the condition here. Or tension AD is let us say 0.001 Newton, just like that. So Rx is 0 to be systematic. So it is negative 48 over 53 tension AB, or P, which is, let's begin with the positive value P, which is 1,200, then minus 48 over 53 tension AB, then minus 12 over 13 tension AC. Then tension AD is not involved because that's part of the analysis. What if tension AD is 0.0001 Newton? So it's still taut. So that's still 0. Simplifying, 48 over 53 tension AB plus 12 over 13 tension AC equals 1,200. So see, that's part of the analysis. So you might say it's easy, but that's the trick here. Then Ry equals 0, and it is Q positive, then minus 12 over 53 tension AB, then minus 3 over 13 tension AC. And that's it. Simplifying, 12 over 53 tension AB plus 3 over 13 tension AC, and minus Q equals 0. We just transpose everything to the left. Then third, RZ is 0. So we have 19 over 53 tension AB minus 4 over 13 tension AC. And tension AD is not involved because we set it to almost 0. So simplifying, 19 over 53 tension AB minus 4 over 13 tension AC equals 0, equation 3. So solving these three equations simultaneously by substitution, elimination, or whatever available basic tools in simultaneous linear equations you master, then we can find tension AB equals 605.7 newtons, tension AC equals 705 newtons, and Q equals 300 newtons. Now, for the second part, if Q is 0, that's also part of the analysis, then definitely AD will have a value, because if Q is 0, these tensions in AB and AC will resist the value of P. So there is tension. They are going downward. And then the downward components of tension will be resisted by tension AD. So the more AD will be taught, but we still solve that. So tension AD for this analysis would be, will have a value. This is questionable. So we will now involve tension AD. So same, Rx is 0, then equation 1 would become 48 over 53 tension AB plus 12 over 13 tension AC, then negative, positive, or minus 48 over 61 tension AD equals 1200 from equation 1, because they were made actually negative, and tension AD is also negative. We just leave tension AD negative value and we transpose everything to the left. So equals 1200. So this would now be equation 1. So negative, Rx. So that's why you have 48 over 53 plus 12 over 13 tension AC plus 48 over 61 tension AD equals 1200. Then equation 2 would become 12 over 50, negative 12 over 53 tension AB, negative 13, negative 3 over 13 tension AC, then positive 36 over 61 tension AD equals 0. That would become to equation 2. Then equation 3 would be RZ 0, so 19 over 53 tension AB minus 4 over 13 tension AC, then minus 11 over 61 tension AD equals 0. And solving these three equations simultaneously, we'll have values for tension AB, tension AC, and tension AD. That's why tension AD will be taught. And therefore, Q would be from 0 less than equal to Q, and Q must be less than 300. Q should be less than 300, not equal to, because if it is exactly equal to 300, then the tension in AD would be 0. But if it is less than 300, the tension in AD will be zero point 0 something or greater than 0. So that's why the answer is 0 less than equal to Q less than 300 newtons. That's it for this problem. Level 12, a rectangular plate is supported by 3 cables as shown. Knowing that the tension in cable AD is 520 newtons, determine the weight of the plate. So as usual, we express its tension into vector form. Tension BA is tension AB, but it is directed from B to A because it is a tension. Then remember, there's a weight here of 5. There's a weight here at O. So tension AB or tension BA is directed to the right point. So it is magnitude of tension AB times quantity 0.32I plus 0.48J upward, then backward negative 0.36K over square root of 0.32 square plus 0.48 square plus 0.36 square. So tension AB in simplifying is magnitude of tension AB times 8 over 17I plus 12 over 17J minus 9 over 17K. Next, tension AC or tension CA in that direction. So it is leftward, upward 480, and backward 0.36. So it is magnitude of tension AC, quantity negative 0.45 I plus 0.48 j minus 0.36 k over square root of 0.45 square plus 0.48 square plus 0.36 square. Simplifying, it is magnitude of tension AC quantity negative 0.6 I plus 0.64 j minus 0.48 k. And finally, for tension AD or DA, it should be DA, but it's still the same. It is going to the left, so negative 0.25 tension AD times, which is 520 times negative 0.25 I plus 0.48 J, then plus 0.36 K over square root of 0.25 square plus 0.48 square plus 0.36 square. So the components of tension AD are along X negative 200, along Y 384 newtons, and along Z 288 newtons. So to be systematic, Rx is 0, and that is equal to 8 over 17 tension AB, then negative 0.6 tension AC, then minus 200. So simplifying, 8 over 17 tension AB minus 0.6 tension AC equals 200. Call that equation 1. Then Ry equals Rz first equals 0, so that we might be able to solve some certain values here. So we have negative 9 over 17 tension AB, then negative 0.48 tension AC, then plus 288, and that's it, because the weight has no Z component. So simplifying, 9 over 17 tension AB plus 0.48 tension AC equals 288. So solving these two equations simultaneously by elimination or substitution, whatever method you conveniently employ. So we have tension AB is 494.5, tension AC is 54.55 newtons. Then finally, Ry is 0, and that is equal to 12 over 17 tension AB, 12 over 17 of 494.5, then plus 0.64 of tension AC, 0.64 of 54.55, plus 384, this is Ry. Then remember, minus the weight of the plate, then minus W. So W is 12 over 17 of 494.5 plus 0.64 of 54.55 plus 384. So we can now solve W equals 768 newtons. Level 13, a horizontal circular plate weighing 600 newtons is suspended as shown from 3 wires that are attached to a support at D and form 30 degrees angles with the vertical. Determine the tension in each wire. So this is the given figure. So tensions would be from bottom to top. And remember, weight of plate, circular plate, is 600 newtons. So for AD, since each cable wire makes an angle of 30 degrees with the vertical, you solve for the component of tension in AD along AO first before you compute the X component of tension, which is opposite to 50. So this component along AO or along XZ is tension AD sine of 30. Remember, that's 30 degrees. Then, because it is going towards the positive x-axis, then sine of 50. So tension AD, Rx is 0, and it is equal to tension AD sine 30 times sine 50. The X component of tension AD is component along AO, which is tension AD sine 30. That's the component along AO. Then along X, we multiply further by sine 50. It is opposite to 50. Then BD is going to the left, so negative. Along BO, it is tension BD sine of 30 again. Then because it is adjacent to 40, so times cosine of 40, but it is negative because it is going to the negative x direction. So tension BD sine 30 cosine of 40 degrees. That's the x component of tension BD. And finally, for CD, along CO is tension CD sine 30 again. It is adjacent and going to the left because it is in that direction. So negative tension CD sine 30, then adjacent to 60, so cosine 60. Tension CD sine 30 times cosine 60, but it is negative. So we divide everything by sine 30. We can simplify it to tension AD sine 50 minus tension BD cosine 40 minus tension CD cosine 60 degrees equals 0. And let's call that equation 1. Next, Ry equals 0. So all tensions are upward, and since all wires makes an angle of 30 degrees with the vertical, their vertical components are all positive, and you just multiply cosine 30. So tension AD cosine 30 plus tension BD cosine 30 plus tension CD cosine of 30. Then minus the weight, 600. So divide everything by cosine 30. So simplifying tension AD plus tension BD plus tension CD equals 600 over cosine 30. Call that equation 2. And finally, RZ is 0. The component of resultant is 0 because this is in equilibrium. So AB is negative. So again, let's compute the component along AO first, then adjacent, so times cosine 50. So it is negative tension AD sine 30, then times cosine of 50, negative. BD also is in the negative z direction. So tension BD sine 30 minus tension BD sine 30, then it is opposite to 40, so sine 40. Minus tension BD sine 30, then sine 40 degrees. Then for CD, it's forward towards the z. Tension CD sine 30, which is that, and opposite to 60, so sine 60. Positive. Tension CD sine 30, sine 60 degrees. So divide everything by sine 30, which simplifies to negative tension AD cosine 50, negative tension BD sine 40, then positive tension CD sine 60 equals 0. So equation 3. Solving these three simultaneous equations by any available method you have. So tension AD is 295.2, tension BD is 102.5, and tension CD is 295.2 newtons. So they are equal, A and D, because this is 50 degrees, so they are symmetrically arranged on one side on this Z axis. That's why the tensions for AD and CD are equal. Level 14, a container of weight W is suspended from ring A. Cable BAC passes through the ring and is attached to fixed supports at B and C. Two forces P equals Pi and Q equals Qk are applied to the ring to maintain the container in the position shown. Knowing that the weight W is 376 newtons, determine P and Q. So this is the given figure. Remember that BAC passes through the ring, and the ring is smooth. So therefore, whatever is the tension in BA, that's also the tension in AC. P is towards the positive x-axis, Q is towards the positive z-axis. That's why in vector form they are written here. So we will call tension in BAC as T. The magnitude is T. So that tension AB in vector form is T, then negative 0.13 I, magnitude of tension AB, which is T, quantity negative 0.13I, positive 0.4J, then positive, it's forward 0.16K, over square root of 0.13 square plus 0.4 square plus 0.16 square. Simplifying, tension AB is T, negative 13 over 45I plus 8 over 9J plus 16 over 45K. Tension AC is magnitude T, quantity negative 0.15I, then upward 0.4J, backward 0.24, negative 0.24K. So over square root of 0.15 square plus zero point 0.4 square plus 0.24 square. So I hope that you find expressing a force in vector form a routine now, because we keep on doing that. Simplifying, tension AC is T, quantity negative 15 over 49I plus 40 over 49J minus 24 over 49K. And that's it. Then set Rx 0, and it is negative 13 over 45T, negative 15 over 49T. Then we have plus P here, which is P. So therefore, simplifying, combining T's, negative 13, 12 over 2205T plus P equals 0. Call that equation 1. Ry equals 0. Then we have 8 over 9T. Then plus 40 over 49T. Then weight minus the weight, which is 376. So we can solve now the tension. From this equation, 376 divided by quantity 8 over 9 plus 40 over 49 is 220.5. Then substitute T in equation 1, we can now solve for P. So negative 1312 over 2205 times 220.5 plus P equals 0. So P is 1312 times 220.5 over 2205, and that is equal to 13131.25 newtons. Then RZ is 0. We have 16 over 45T, and T is 220.5 minus 24 over 49T times 220.5. That's it. Then plus Q. So we can now solve for Q. Q is 29.6 newtons. So level 15, a container of weight W is suspended from ring A to which cables AC and AE are attached. A force P is applied to the end F of a third cable that passes over a pulley at B and through ring A, and that is attached to a support at D. Knowing that W equals 1000 newtons, determine the magnitude of P. So again, we have cable BAD, which is attached to a ring. B through ring A, and that is attached to support D. So because the force applied in BA is P, whatever tension in BA, that's also the tension in AD, which is P, because this cable is passing through the ring again. So it is just a one cable. We will denote the tension there as P. So tension in AB is equal to magnitude, which is P. It is directed to the left, negative 0.78I, upward 1.6 J, over square root of 0.78 square plus 1.6 square. So it is P, quantity negative 39 over 89I plus 8 over 89J. Tension AD is also P, and it is positive one tension AD, which is P. So P times quantity 1.3I plus 1.6J, then plus 0.4K. Square root of 1.3 square plus 1.6 square plus 0.4 square. So it is positive, it is forward towards the z-axis. So simplifying, tension AD is P quantity 13 over 21I plus 16 over 21J plus 4 over 21K. Then, vector form of AC. Tension AC is magnitude of tension AC, quantity 1.6 J, then positive 1.2 K over square root of 1.6 square plus 1.2 square. There's no X movement, so Y and Z components only. Simplifying, tension AC is tension AC quantity 0.8 J plus 0.6 K. Finally, tension AE, it is negative 0.4. Tension AE is magnitude of tension AE quantity negative 0.4 I plus 1.6 J, then minus 0.86 K. So again, negative tension AE, negative 0.4 I plus 1.6 J minus 0.86 K over square root of 0.4 square plus 1.6 square plus 0.86 square. Simplifying, tension AE is tension magnitude of tension AE times quantity negative 20 over 93I plus 80 over 93J minus 43 over 93K. So to be systematic, Rx is 0 equals negative 39 over 89P plus 13 over 21P, then minus 20 over 93 tension AE. So we can express tension AE in terms of P. Tension AE is 0.8409P from this equation. We can combine this, transpose to the left so that you can express tension AE in terms of P. Ry is 0. So we have 80 over 89P plus 16 over 21P plus 0.8 tension AC plus 80 over 93 tension AE, and don't forget minus 1000. So substitute the value of tension AE, which is in terms of P, from here. So 0 equals combining these two P's here. That's the value, then plus 0.8 tension AC plus 80 over 93 of tension AE, and tension AE is 0.8409P minus 1000. Simplifying, 2.3842P plus 0.8 tension AC equals 1000. So call that equation 1. Then RZ is 0. And we have 4 over 21P plus 0.6 tension AC, then minus 43 over 93 tension AE. So that's it. Then replacing tension AE in terms of P, so 0 equals 4 over 21P plus 0.6 tension AC minus 43 over 93 of 0.8409P. So combined with P here, we can express tension AC in terms of P as 0.3305 of P. Finally, tension AE and tension AC in terms of P, substitute in equation 1 here, then we can now solve for P. So 2.3842P plus 0.8 of 0.3305P equals 1000. So we can now solve for P. P is 377.6 newtons. Level 16, collars A and B are connected by a 25-inch long wire and can slide freely on frictionless rods. Determine the distances X and Z for which the equilibrium of the system is maintained when P is 120 pounds and Q is 60 pounds. So P is directed along positive x-axis, so that's the x component of the tension in AB, and Q is directed towards the z-axis, so that's the z component of tension in AB. So what we do not know is the y component of tension in AB. So in vector form, tension in AB is magnitude of tension AB, quantity xi minus 20j, and plus zk over square root of x squared plus 20 squared plus z squared. But this square root of x squared plus 20 squared plus z squared is the length of the wire, which is 25. So we can replace that to TAB quantity xi minus 20j plus zk over 25. So TAB times x over 25 is the x component of force, which is P and 120. So TABX is 25 times 20, 3,000. So what we need is the tension in AB. And TABZ over 25 equals 60, the Z component Q. So TABZ is equal to 1,500. These are our working equation to solve for X and Z later. Then TABY is negative 20 over 25 of tension AB. So that's the Y component of the tension. So it is negative 0.8 tension AB. So tension AB square equals is X component of tension square. The ABX is 120 pounds. The Y component of tension is, the Z component of tension is 60, and the Y component of tension is negative 0.8 of tension AB. Tension AB square is X component of tension square plus Y component of tension square plus Z component of tension square. So from here, we can now compute tension in AB. Tension in AB is equal to 223.6 pounds. Substitute above, 223.6 times X equals 3,000. So X can now be computed, 13.42 inches. Then here, 223.6 times Z is 1,500. So Z is 6.708 inches. So that's it for this problem. It's short, but the trick is very nice. Collars A and B are connected by a 525 mm long wire and can slide freely on frictionless rods. If a force P, 341 Newton J, is applied to collar A, determine the tension in the wire when Y is 155 mm, and B, the magnitude of the force Q required to maintain the equilibrium of the system. So this is the figure. This is almost similar to the preceding problem. So therefore, the Y component of tension is P, which is 341. The Z component of tension is Q, but it is unknown. And another unknown is the X component. So tension AB is equal to magnitude of tension AB times quantity 0.2I plus YJ, then plus ZK over length of wire 0.525 meter. So from there, the ABX, the X component of tension is 0.2 over 0.525 of tension AB. Simplifying, that's 8 over 21 tension AB. The ABY, Y is given 0.155 meter, 0.155 tension AB over 0.525. Simplifying, that's 31 over 105 tension AB. And the Z component is Z tension AB over 0.525. But we can compute the value of Z because the length of the wire is given. So 525 square equals X square 200 square plus Y square 155 square plus Z square. So Z in mm is 460 mm. So substitute here, the Z component of tension is 0.46 over 0.525 of tension AB, and that is 92 over 105 tension AB. So since the Y component is known, 31 over 105 tension AB is 341. So we can now solve tension in AB. So tension in AB is 1155 newtons. Then Q, which is the Z component, is this one. TABZ is Q, 92 over 105 of 1155. So Q is equal to 1012 newtons. Last problem, four balls of equal radii form a pyramid supported by a smooth horizontal plane surface as shown in the figure. The three lower balls are held together by encircling string as shown. Determine the tensile force T in this ring if the weight of each ball is W and the surfaces of the balls are perfectly smooth. Neglect any initial tension that may be in the string before the top ball is placed upon the other three. So we already have an experience about this in the preceding problem. I think it was level 8 problem. So I hope you will not find a hard time in computing for the reactions between the top sphere and the lower three spheres, and as well as the components. Remember, it forms a regular tetrahedron. This is the regular tetrahedron. Let's consider the upper sphere first. So center to center of the lower three spheres will have length of 2r, also equilateral triangle. That's the weight of the upper sphere. So remember that we have to draw a line towards the center to here, which is the centroid of the equilateral triangle. We will call the height of the equilateral triangle of the bottom base as h1. And the reactions of between the lower three spheres and the upper sphere is the same, r1 by symmetry. So call that h1. h1 is either 2r sine 60 or square root of quantity 2r squared minus r squared. And that's also perpendicular to compute that height. So this is 2/3 of h1 from vertex to centroid foot of this perpendicular, and that is h. So h1 is 2r sine 60 degrees or square root of quantity 2r squared hypotenuse squared minus r squared. Hypotenuse 2r squared minus r squared. So h1 is equal to r square root of 3. Then 2/3 of h1 is 2/3 of quantity r square root of 3. So that we can compute h, which is square root of hypotenuse 2r quantity square minus 2/3 of h1, which is 2/3 of r square root of 3 quantity square. So h is 2r square root of 6 over 3. Then some r vertical equals 0. So these three reactions are denoted R1. They have equal magnitude and equal y vertical component, which is R1 times h over hypotenuse, which is 2r, or vertical component of distance, R1 times vertical component of distance divided by distance, which is 2r. So 3r1 quantity 2r square root of 6 over 3 over 2r minus w. So cancel 2r, cancel 3. So this is r1 square root of 6 minus w equals 0. Or r1 is w over square root of 6. Then we analyze this one. Let's say this sphere here. That's the top view. And this is also the top view. But we transfer T and T here because the angle here is 60 degrees. They are transferred at the center by principle of transmissibility of a force. They are equal, same sense. So each tension make an angle with the horizontal component of R1. This is R1. The horizontal component will push this sphere and it is prevented by this tension here. So we consider only the horizontal component of R1 because that's the force that will be resisted by these two tensions T here. And the component of tension along this axis here, R1H, is T cosine of 30. So we set R1H to R1H is R1 times 2/3 of H1 over distance 2R. So since R1 is W over square root of 6 and this is square root of 3 over 3, if we simplify, we cancel 2R. So R1 is W over 3 square root of 2, R1H. Then finally, RH is 0. So RH is 0 equals these two tensions are positive in that direction. So each component is t cosine 30 and they are 2. So 2 times t cosine 30 degrees, then minus R1H, which is W over 3 square root of 2 equals 0. So 2t cosine 30 is t square root of 3. Therefore, t is W over 3 square root of 2 over square root of 3. So therefore, t is W over 3 square root of 6. That's the exact value. That's it. That's the end. And I hope that you were able to grasp to imagine the explanations, because these are all mathematics, trigonometry, components. You find a hard time understanding it, it's because of your trigonometry, not statics, but it's your trigonometry. So you have to master trigonometry first before proceeding to statics problem.